Hi everyone, welcome to Byju's Exam Prep. Myself Sandeep Kakkar, your maths mentor. Welcome to the success match. Today the very first session about number system topic. We are going to start classification of numbers today, but I will give you the complete detail about the numbers. So definitely you are gonna enjoy the session and it is gonna be awesome output from this batch as well. So good evening everyone. Good evening Amit, Rishika, Akhil, Karina, Krishma, Surya, Manish, Munish, Vijay, Nimish, Himanshu, Akash, Chichamo, Parkovan, Ji. Good evening to everyone. Definitely, beta, if you want to make notes out of this, you can, but you will get the PDF as well. Whatever I will teach you, you will definitely get the PDF of that, and rest is your choice. Okay, T Matthew, good evening. Akash, good evening. Gaurav, good evening. Varun, Ji, everyone, good evening. So let's start the fantastic topic out of your syllabus. As this is very first session, I would like to say something that if you find any difficulty, any doubt, you are most welcome to ask through live chat. You can write the message, I will read it, I will definitely resolve the query if it is logical. Try to listen more, write only those things which are more important. Okay, you will get the PDF as well, you will get the recording as well. Okay, you are also excited for the same. Okay, Rishika, always beta. Pallav, Yasmin, Ji, good evening everyone. So today the very first session about number system. If I will talk about number system is not a small topic. It's a big topic, most important, most interesting, one of the most important and interesting topic as well. In number system, we will discuss about classification of numbers, the very first session, which I will cover today. Then divisibility rules, remainder theorem, unit digit, number of zeros, HCF, LCM, number of factor, factorial and sum of natural numbers. All these things I will cover in number system. So let's start with classification of numbers. In this classification of numbers, in this session we will discuss about complete numbers, variety of numbers and their properties in detail. If I will categorize these two, if I will categorize numbers, there are two. One is real, other is imaginary. One is real, other is imaginary. I am telling you guys, I will discuss in detail from basic to high level. Whatever it is important for your exam, I will cover everything. Not even a single thing I'm gonna leave. I will cover everything. So let's start with the very first thing, which is about imaginary numbers. This is a small thing. We will do it, we will discuss it, and I will finish it. Then I'll move to real numbers. So let's start with imaginary numbers first. Everybody know if the value under the root, if negative, let's take minus 16, root of that. I can write this number as root of minus 1, root of 16. Root of 16 will give you 4. And this root of minus 1 can be written as iota. Iota is both. Iota is to represent value under the root with the negative sign. If value under the root with the negative sign, it means root of minus 1. We can represent this one as iota. Is the point clear to everyone? Value under the root with the negative sign, root of minus 1. I can write this one as iota. Then come to if iota is root of minus 1. So if I will take iota square, so beta this will be equal to minus 1. Iota is root of minus 1 and iota square is, this is minus 1. You should remember these two things. Now about imaginary numbers, complex numbers we used to call. If the value under the root is negative, it means root of minus 16. I can separate. I can write this one as root of minus 1 into 16. Then root of minus 1 separately, multiply root 16. This will give you 4, this will give you iota. So finally you will get 4 iota. If I will take root minus 23, root of minus 23, I can represent this one as root of minus 1 into root of 23. So this one is iota, this is root 23. It cannot be taken out completely. So this is root 23 iota. That is it. Value under the root can come outside completely or may not. But value under the root with negative sign will remain same and can be represented as iota. So I did the same. Imaginary numbers, if value under the root, if negative, then this is imaginary. Let's take, if I will take root of minus 12. Why I'm taking this example, you can see root of minus 12 can be written as minus root of minus 1. And this root of 12 can be taken as 2 2s are 4, 4 3s are 12. This will give you 2 root 3. Mean to say, if you will take root of minus 1 and root of 12, and root of 12 will be taken as 2 root 3. And this is minus 1 ka root. So this will give you iota. So this complete will give you 2 root 3 iota. If this point about imaginary numbers, if it is clear, please show me the thumb, everyone. If it is clear, everybody be passionate, and concentration must be 100%. So I will cover everything, don't worry. This is my responsibility. I would like to see all of you as my officers, and I know you will definitely crack the exam. But your concentration, your dedication must be 100%. Whatever it is important for your exam, I will give you everything. So about syllabus, about questions, about methods, I am there for you. You just practice the complete, you just listen carefully in the session. That's the only thing I expect from you. Okay? Please explain root 12. Okay, okay, beta. Okay, Anju. I want to say root of minus 12. If this is given, I can write this one as root of minus 1 into root of 12, right? But this root of 12 can be factorized 2 into 2 into 3 in the prime factorized form. This root of minus 1, this is iota, okay, beta? And out of this 2 and 2, 1, 2 can be taken outside, 2 root 3 is left. So into iota is there, so 2 root 3 iota is the total final outcome. Is the point clear? Now clear, beta, Anju? Okay, that's great, that's great. Now come to, sometimes you will, in small exams, uh, you will find this type of questions, iota to power 84 plus iota to power 100. Maybe you will get. So iota to power 84 plus iota to power 100. If you will get this question, what will you do and what will you get as an answer? Iota to 84 can be written as iota 2 square to the power 42 and iota 2 square to the power 50. Now iota 2 square is minus 1 to the power 42 is plus 1. This is minus 1 to the power 50 is plus 1. Overall value is 1 plus 1. 2 is the right answer. Everybody can do that. Iota to 84, iota to 100. Sum of these two will give you 2 as the final value. Okay, beta? If I will take iota to power 42 plus iota to power 52, if this is the expression, then what will you get? Tell me, everyone. Iota to power 42, iota to power 52. How much you will get out of this? Tell me. Good, 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 good. Chaliye, let's see. Iota to 42 can be written as iota to 2 to power 21 and iota to power 2 to the power 26. So this will give you minus 1. Iota square is, this is minus 1 to power 21. This is minus 1 to power 26. This will give you minus 1. This will give you plus 1. Overall, the sum is equal to 0. That is it. Everybody can note down. And I expect everybody is able to understand. Okay. T. Matthew is asking how to solve root of minus 7. It cannot be solved. It can be written in the imaginary form. Root of 7 into root of minus 1. Root of 7 cannot be completely come outside. Root of minus 1 can be taken as iota. So root 7 iota, that is it. Okay, beta? T. Matthew, this is the only thing you can do for this. Karina, I'm telling you, root of minus 1, this is equal to iota. So if I will take square on both sides, iota square will be minus 1, square on both sides. If root of minus 1 is equal to iota, so iota square will be minus 1. So I took the question as iota to power 42, iota to power 50. So iota to power 42 can be taken as iota to 2 to power 21, iota to 2 to power 26. Iota to 2 is minus 1, minus 1 to power 21. The power is odd, you will get minus 1. Iota to 2, this is minus 1, minus 1 to 26 will give you plus 1. So overall sum will be equal to 0. Okay. Now, if somebody is saying that iota to power, if 53 is given, iota to power 53 is given, iota to power 57 is given, what will you do? Then what will you do? It can be taken as iota to power 2 to power 26. But you will say that this is 26 into 2 is 52. So this is 53. So how much extra it is still left? Iota to power 1 is still left. Is the point clear? Iota to 57 can be taken as iota to 2 to power 28 into iota. Okay, beta? This you know, this is minus 1 to 26 is plus 1 and this will give you iota. This is what? This is minus 1 to power 28 will give you plus 1. It means will give you iota here as well. Iota plus iota, you will get 2 iota. 2 iota means 2 into root of minus 1. Answer can be formed in this form or in this form. You will have to check this form or this form. What is given in this? You will go accordingly. Okay. Now let's come to the next. Now come to classification of numbers in which we are going to cover about real and imaginary. Imaginary numbers I have already explained. You can see everyone. I started with real and imaginary. I started with imaginary first. I told you the value under the root with negative sign will give you imaginary value. It means whenever the value under the root is negative, it means this is imaginary. And iota will definitely be there. Iota is root of minus 1. Iota square is minus 1. I have given you so many examples as well to understand what was that about imaginary numbers. Okay. Matthew, it is my first learning. This is also, oh, thank you, beta. My Okay, अगर आप मेरी तारीफ करना चाहते हैं, if you want to appreciate me, just give me the result to become an officer, and I would like to see that you are getting something, right? Come to now about real numbers. Real, I will discuss about real contain rational and irrational. Rational, irrational are terminating, non-terminating, natural, whole, integer. I will cover all these things right now. Okay, let's move further. Let's start with real number first. Real number are those numbers which can be represented on number line. So you will ask them which numbers we can represent on number line. Any number you can represent on number line other than imaginary. If the number is not imaginary, if the number is 5 by 7, if the number is 2 by 17, if the number is 0.327, if the number is minus 15, if the number is minus 389, if the number is 9873, this number, every number can be represented on number line. Every number, just listen carefully. In exams, you can get these type of questions. Examiner will ask you that which number can be represented on number line? Can rational number can be represented on number line? Yes, rational can be represented on number line. Irrational can be represented on number line. Natural, whole, integer, rational, irrational, terminating, non-terminating, perfect square, not perfect square. Any number can be represented on number line. Which is not imaginary, it can be represented on number line. If I will take, let's take root of minus 17. Can I represent this number on number line? A big no. A big no. Because this is not real, this is imaginary. If value under the root having negative sign, so this is imaginary, can never be represented on number line. Any other number, the small definition, everybody listen again. A small definition about real numbers is any number which is not imaginary is real number. And every number can be represented on number line other than imaginary. Any number can be represented on number line other than imaginary. I expect this is clear to everyone. Let's move further. Rational numbers. Out of real numbers, I discuss about real numbers now. In real, the numbers are either rational or irrational. In rational numbers are those numbers, rational, ratio, fraction, one are the same thing. Okay, beta? Ratio, fraction, one are the same thing. The fraction which is P by Q, right? P by Q form. Fractional, rational, it is same. So rational number are those numbers which can be represented in the form of P by Q, in which P and Q are both integers. Okay? In which both P and Q are integers such that Q is not equal to 0. P by Q form, Q not equal to 0, it is rational. I will ask you, is 2 by 3 rational or not? Tell me fast. Yes, 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 2 by 3 rational. If I will ask you 4 by 5 is rational or not? 4 by 5 is rational. Is 0.739, is this rational or not? Yes. 739 by 1000, this is P by Q form, this is P by Q form. Now if I will ask you 27 is rational or not, tell me. 27 is rational or not? Tell me fast. Yes, of course, because 27 can be represented as 27 by 1. So obviously this is P by Q form. So any number which can be represented in P by Q form, it is rational. Only thing, Q cannot be equal to 0. If I will take 17 by 0, this is practically not possible. This is undefined. This is undefined. Infinite, we used to call, right? So 0 should not be there in the denominator. Q is never equal to 0. That's the only thing you will have to remember. Okay. Rational are terminating or non-terminating. If I will take 1 by 2, 1 by 2, why this is terminating? The term itself, terminate. I will terminate you. If somebody is saying to his person, to the officer, I'm gonna terminate. So I'm gonna terminate you. It means finish, end, complete. So 1 by 2 means 0.5. Finish, completely divisible. Now come to 1 by 3. 1 by 3 is 0.33333. It is not completely divisible, right? Both are rational. This is rational. This is rational. Both are rational. Okay. Krishna, what you want to ask? 10 by 7 what? 10 by 7 what? 10 by 7 kahan hai? Where is 10 by 7? I don't understand. Yes, this is rational, beta. P by Q. That is it. This is rational. 10 by 7. This is rational. 100% rational. Okay. Any other confusion? Is it clear, beta? Now come to this is terminating. Okay. Termi. Yes. देखिए, there is a term which is fraction. Okay. Fraction में the point you want to ask Krishna, this is about fraction. If I will take 4 by 3, is this fraction? This is not fraction. 3 by 4 is fraction. बचा हुआ हिस्सा, the remaining part is fraction. Fraction is 3 by 4. Fraction is 3 by 4. 4 by 3 is not fraction, but this is rational, 100% rational. Okay beta. I will discuss about it, Jasmine. If p is equal to 0, that is possible, p Matthew, t Matthew. Okay beta. Yes, that is great, very good. Rishika, this is improper fraction. Improper fraction. This is improper fraction. This is proper fraction. There is a little bit difference between these two. If p is greater than q, then this is improper. If p is less than q, then this is proper fraction. Two terms. I will come to every single point. Don't worry. Everything. Improper or mixed fraction, one are the same thing. So let me complete first, then you will be more clear by that, and you will not find even a single problem into that. If I will give you, let's take 8 by 3. So I can divide 3 2s are 6, 2 plus 2 by 3. Or we can write 2 by 3. So this is mixed fraction. Okay. Or we can say improper fraction. Which one is proper? If I might be taking 3 by 8, this is proper fraction. I know the depth of every single term. So yes, terminating, non-terminating, I'm telling you. Let me complete, let me speak now. Let me speak. I think the point is clear, Krishna, T Matthew. I think your doubt is clear, beta. Now come to, the student is having the doubt, what about terminating and non-terminating? Beta, understand the English meaning. Terminate, finish. Non-terminating, not finished. So if I will give you an example, let's take 1 by 2. 1 by 2, if you will divide 2 ones are 2 5s, 0.5 you will get. But if you will divide 1 by 3, you will get 0.33333 up to infinite. So this is terminating. Terminating. And this one is non-terminating. Okay? This one is non-terminating. It means it is never finished, never ending. But to stop this one, this repetition, I can put bar on this. And I will definitely give you few examples how you can change non-terminating into P by Q form. How you can change. I'll give you the short trick as well. So let me complete. Okay? We'll go one by one. Nothing I'm going to leave. So I think till this point it is clear. Difference between terminating, non-terminating. Pallav, samajh aa gaya? Pallav, is it clear, beta? Okay? Chaliye, next. Now come to irrational. Rational, if rational is there, it means rational means P by Q. Irrational is what? Now we are discussing about irrational. Irrational is which is not equal to P by Q. Okay. Are those which can never be, which cannot be represented in the form of P by Q. So these are irrational. Irrational are what? Yes, if can be represented in P by Q form, are rational. If cannot be represented in P by Q form, are irrational. So root 2, the value is 1.414. We used to write yes or no, but this is not complete. This is not ending. It is going on. Root 3, 1.732. We used to write. It is never ending, never ending. Irrational are always non-terminating. Or you can say never ending. Are always, whenever you will talk about irrational, you can never find out exact value of irrational. Are always non-terminating, never ending, right? Are never ending. And I can say but, and non-repeating as well. And non-repeating as well. There is no trend. As in rational numbers, you got a trend. If I will take 2 by 3, you will get 0.666666. So it can be represented at 0.62 per bar. 6 is repeating itself. This is P by Q form. This is rational. This is P by Q form. But in this case, in this irrational, this is always non-terminating, never ending. It will go on, go on, go on, but non-repeating as well. Non-repeating as well. Okay, beta. Till this point, it's clear, I think. There is no confusion I expect from everyone. Can we say non-terminating rational? No, 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 no. This is non-terminating, non-repeating as well. There was some repetition. In those non-terminating, there was some repetition. There was something is recurring, repeating. A trend is there, but here there is no trend. Okay. Achha, can we represent irrational numbers on number line? Tell me yes or no, everyone. Can we represent irrational numbers on number line? Yes or no? Chichamo is saying no. Else everybody is saying yes. That is great. Beta, initially I told you, other than imaginary, every number can be represented on number line. Yes, it was in ninth standard book. If you do remember, there was a way as well. They used to make a perpendicular as well, and they used to represent the value of root 2. Do you remember? On number line, they used to make a right angle triangle, and they used to represent root 2, right, root 3. So there was a way. If you will check, you will come to know. I'm not going into that because it is not that much important for you. It's not at all important for you. You just remember that irrational are those which can be presented on number line but cannot be written in the P by Q form. Can never be written in P by Q form. I think this is clear. We should move on. Okay. Yes, of course. 9th class NCERT book. Now come to rational are terminating, non-terminating, but repeating. Irrational are always non-terminating, non-repeating as well. In brief, this is these lines. Okay. Let's move on. How to change rational, non-terminating, recurring into P by Q form. I was telling you now, I will definitely let you know how to change a non-terminating recurring into P by Q form. So if you find, let's take 0.457 and 57 is repeating itself. Okay. And you want to change this one in P by Q form. P by Q form, you will have to change this particular 0.457, 57, 57, 57. This is coming again and again, and this is never ending. Okay. But there is a trend you can see. How can you change this one in P by Q form? I will tell you. First of all, what should you do? You must write the number in such a way that repeating term you must represent with a bar on that. Okay. So 57 is repeating itself again and again. So I have represented 57 bar on that. Okay. The very first thing. Now, how to change in P by Q form? First of all, the value after the decimal, take it completely. Value after the decimal, it is 457. Minus the value which is not repeating. After decimal, I'm talking about. Before decimal, I'm not talking about. If after decimal, take the complete value like this. And which is not repeating, subtract that term. Divide by. How many digits are repeating? Only 2 digits are repeating. So 2 times 9 you will have to take. How many digits are not repeating? 1 digit, so 1 times 0. 0 is because of non-repeating digits. And the 9 I write because of some value is repeating itself. So there are 2 digits, so 2 times 9 you will have to take. Okay. I think this is clear. If you will solve, you will get 453 by 990. Everybody can note. Okay. Now let's take one more example, beta. If I will take 0.543 and 3 is repeating itself, what will you do? What will you do in this case? 0.543, the bar on 3. What will you do? The value after the decimal take completely. Subtract the value which is without bar. The very first thing, what should you subtract? The value which is without bar. Now, 1 digit is repeating, so 1 times 9. 2 digits are not repeating, so 2 times 0. That is it. Okay, any confusion till now, please ask, but make it fast. If you want to ask something, please make it fast and tell me what is your doubt if you do have any. Okay. Yes, man. Very good. Rishika, good. Okay, is that clear? Okay, that's great. Nobody's having the doubt. Now come to the simple thing. Ganesh, but this is a simple thing. As you are asking 1 by 6, right? 1 by 6 is there. 0.1 is there. 6 are 6. You will have to take 1. Divide by 6. First decimal will be there. 6 ones are. Then 4 is left. 6 are 36. Then again 6 are 36. Then again 4. Then 6 are 36. Repeating itself, yes or no? So 0.166666. It is repeating. So you can stop it and you can write 0.166 per bar. That is it. Okay. Now if you want to change, then 16 minus 1 upon 90. That is it. 15 upon 90. 1 by 6. I have given you the complete explanation. P by Q form to this and this to P by Q form. What if all right side digits repeat? Okay, one student is asking, if let's suppose 73, 732, all digits are repeating, then the question is simple. Then the question, Praveen Kumar, it is simple. 732, take completely. Is there anything to subtract? No, there is nothing to subtract. Take it same. How many digits are repeating? 3 digits are repeating. So 3 times 9. Any digit which is not repeating, there is not even a single digit. So this is the right answer. That is it. Okay, beta. If I will give you 5 57 के ऊपर बार, what will you get? Tell me everyone, tell me fast, fast, fast. 0.5757 के ऊपर बार, what will be the value? Tell me fast, everyone. 57 is there. Then how many digits repeating? 2 digits. So 57 by 99. This is the right answer. Okay, beta. That is it. Let's come to next. Natural numbers. Natural numbers, everybody know, start from 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, up to infinite. If I will ask you 98,736, is this a natural number? Of course, yes. This is a number. Natural number means it should be complete. It should be complete. Complete means what? Decimal should not be there. Very first thing. It should be positive as well. No negative. It means positive. It means complete. Positive and complete both. Okay, beta. All counting numbers 1, 2, 3, 4, 5. All numbers, right? Let's come to next. Whole numbers. All natural numbers including 0 as well. All natural numbers including 0. Natural number 1, 2, 3, 4, 5, 6 up to infinite. Whole number is what? Including 0 as well. That's the only thing. So it means whole number is same as of natural. Only thing which you are supposed to add, this is 0. That is it. What about integers? Integers is what? If you have ever seen, there is a number line. On number line, this is 0, 1, 2, 3, up to infinite. Then on other side, -1, -2, -3, up to infinite. It means 1, 2, 3 up to infinite, -1, -2, -3 up to minus infinite, and 0 as well. All positive, all negative, complete numbers, including 0 as well. So that's why. So I can say minus infinity to plus infinity. But decimal should not be there. It should be positive, it should be negative, but complete numbers. It should not be fractions. Okay, beta? Now come to few other terms, which is about prime, composite, co-prime, and perfect numbers. Prime is what? Anybody? Prime number. The number which is not divisible by any other number other than 1 or itself. Prime number is what? Numbers which are not divisible by any other number other than 1 and itself. 2 is a prime number. 3, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. So all these till 50, from 1 to 50, all these prime numbers. Okay, beta? Yes, these are divisible by 1. These are divisible by itself. So number is prime. Okay? So important points you should remember. 2 is the smallest prime number. Very first thing. If somebody will ask you, tell me which one is the smallest prime number. The smallest number which is not divisible by itself. And it is divisible by itself in 1 only. It is 2. Then 3, then 7, then 11, then 13. That is going on. But smallest one is 2. And is there any other number which is yes, even number other than 2? No. 2 is the only even prime number. Prime number it is. Even prime number. Okay. Then if they will ask you how many numbers are there less than 50 which are prime. So 15 numbers are there which are less than 50 which are prime numbers. Next, there are 25 numbers less than 50. 25 numbers less than 50. 15 numbers less than 50. Only even number, only smallest prime number is 2. Okay. These 3 points you can remember. Prime numbers clear to everyone. How to check whether this number is a prime or not? Point 2 and 3. Beta, if somebody will ask you that how many prime numbers are there less than 50? How many prime numbers are there? Prime numbers which are less than 50. So 50 से कम prime number कौन कौन से हैं? 2, 3, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. All these are prime numbers less than 50. Yes, if they will ask you less than 100, there are 25 prime numbers less than 100. Here it should be 100. Okay, it should be 100. Less than 100, 25 prime numbers. Less than 50, 15 prime numbers. Okay. Now मैंने उसको correct कर दिया है. I have done it. I think now it is clear at least. There was a small term which instead of 50 it should be in this 100. I have done it. I think you understand now. Let's come to next. How to check whether a number is prime or not? Let's take a number 87. Is this number divisible? Is this number prime or not? It's a prime number or not? What should I do? I will have to take the number which is perfect square. Okay, perfect square which is more than 87. It lies between 81, which is 9 square. It lies between 100, which is 10 square. 87 lies between 81 and 100. It means 9 square and 10 square. It lies between these two. So if any number which lies between these two, so as it lies between 9 ka square and 10 ka square. So if it is divisible by any number which is less than 9, then it is divisible. The value which is less than 9, it is 3, can divide 87. Okay. So the value which is less than 9, if can divide this number, then definitely this number is divisible. It is not prime. If the number is not divisible by any number less than 9, so definitely this is not prime. Okay. I take one more example. Let's suppose 89 is there. 89. Okay. 89 also lies between 81 and 100. It means this is 9 ka square, this is 10 ka square. Is there any number from 1 to 9 which can divide 89? Tell me. From 1 to 9, is there any number which can divide 89? Tell me fast. No. It means you are not supposed to check with every number. You are not supposed to divide 89 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. No, don't divide with every number. Just divide with these numbers only, which are less than or equal to 9. If divide 89, then it is not prime, else it is prime. Okay. Let's suppose if there is a number, let's suppose 43. Okay. Is 43 prime or not? If you don't know, then what will you do? You will have to take 6 square is 36, 7 square is 49. So it means from 1 to 6, you must check is there any number which can divide 43? There is not even a single value from 1 to 6 which can divide 43. The point clear? If it is a 5-digit number, so beta, this is a calculation. This is not exam centric. Look, competitive exam is something different. It does not work according to your imagination. You can think, sir, if I'll give you a number which is too big, which is 10 digits number, so how can you find out this is prime or not? So the only process to check, you will have to take square in between these two. If I will take 43 is a number, take square root of that. In square root in exact values, not in decimal. It is more than 6 square. 6 square 36. It is less than 7 square. From 1 to 7, you will have to check with every number 1, 2, 3, 4, 5, 6. From 1 to 6, with every number you will have to check that 43 is divisible or not. That is the only process. Okay, beta. If you want to check 113, if this number is prime or not, take square root of this. This is 10 ka square is 100, 11 square is 121. So this lies between 10 square and 11 square. Okay.